双语音标领航，注音阅读启蒙，叶兴阳有声读物。
American Handbook of the Daguerreotype, giving the most approved and convenient methods for preparing the chemicals, and the combinations used in the art, containing the daguerreotype, electrotype, and various other processes employed in taking heliographic impressions. By S. D. Humphrey entered, according to Act of Congress, in the year 1858, by S. D. Humphrey, in the clerk's office of the District Court of the Southern District of New York, to J. Gurney, whose professional skill, scientific accuracy, and energetic perseverance have won for him universal esteem. This work is most respectfully inscribed. Preface. There is not an amateur or practical daguerreotypist who has not felt the want of a manual handbook, giving concise and reliable information for the processes and preparations of the agents employed in his practice. Since portraits by the daguerreotype are at this time believed to be more durable than any other style of sun-drawing, the author has hit upon the present as being an appropriate time for the introduction of the 5th edition of this work, the earlier edition having long since been wholly exhausted. The one now before you is presented. The endeavor has been to point out the readiest and most approved methods of operation, and condense in its pages as much practical information as its limits will admit. An extended preface is unnecessary, since the aim and scope of this work are sufficiently indicated by the title. S. D. Humphrey, New York, 1858. Contents. Chapter 1. Polishing the daguerreotype, plate buffing the plate, coating the plate, exposure of the plate in the camera position, developing the daguerreotype, exposure to mercury, removing the coating, gilding or fixing the image, coloring daguerreotype. Point 18. Chapter 2. Coloring backgrounds, transparent, ditto, gilding, dissolvent. Solution for removing speck, solarized impression to purify water. Cleaning, mercury adhesive, paper, black stain for apparatus. Sealing wax for bottles, rouge, rotten stone, potassa solution. Hyposulfite solution, substitute for dew. Gilding solution, solution for increasing the brilliancy of the daguerreotype. Bleaching solution. Cold gilding, neutralizing agents. Buff, dryer, keeping buffs in order, cleaning buckskins. Reflector for taking views. 52. Chapter 3. Bromine and its compounds, iodine and its compounds, chlorine and its compounds, cyanide of potassium, hyposulfite of soda, hyposulfite of gold, nitric acid, nitromuriatic acid, hydrochloric acid, hydrofluoric acid, sulfuric acid, accelerating substances, liquid sensitives, dry sensitives, etc., etc. 72. Chapter 4. Light, optic, solar spectrum, decomposition of light, heat, and actinism, blue paper and color for the walls of the operating room, proportions of light, heat and actinism composing a sunbeam, refraction, reflection, lenses, copying, spherical aberration, chromatic aberration. Point 131. Chapter 5. To make plates for the daguerreotype, determining the time of exposure in the camera, instantaneous process for producing daguerreotype, galvanizing the daguerreotype, plate, silvering solution, daguerreotype without mercury, management of chemicals, hints and cautions, electrotyping, crayon daguerreotypes, illuminated daguerreotypes, natural colors in heliography, multiplying daguerreotypes on one plate, depositing, gilding, practical hints on the daguerreotype. Point 149. Chapter 6. An account of Walcott and Johnson's early experiments in the daguerreotype. Point 188. American Handbook of the Daguerreotype. Chapter 1. Polishing the daguerreotype, plate buffing the plate, coating the plate, exposure of the plate in the camera position, developing the daguerreotype, exposure to mercury, removing the coating, gilding or fixing the image, coloring daguerreotype. Polishing the daguerreotype plate. I shall endeavor to present to the reader the process I have found productive of good and satisfactory results, presenting the same in a clear and concise manner, so that anyone, by following the various manipulations given, will be enabled to succeed. If there is any one part of the process in daguerreotype in which operators fail more than all others, it is in not properly preparing the plate. It has truly been said that it would take a volume to describe all the methods that have been suggested for polishing the plate. I shall confine myself to the following description, which has been successfully practiced, also most generally adopted by our operators, and I believe equal, if not superior to any other method. Yet at the same time it is not of so much importance what particular method is employed, so that it be thoroughly and skillfully carried out. There is a general tendency with beginners to slight this operation, hence the necessity of adopting a system which precludes the possibility of doing so. During many years' study and practice in the art, I have tried numerous methods and substances for the better accomplishment of the end in view, and have finally settled upon the following, as being, so far as experience allows me to judge, the modus operandi best suited to all circumstances. Under no condition would I approve of a method less rigorous or precise. The operator being provided with a bottle of finely prepared rotten stone. Cover the mouth of the bottle with a piece of thick paper. This perforated with a pin so that the rotten stone can be dusted on the plate. Fasten the plate on the holder. Take the rotten stone, beckers can always be depended upon, and dust on lightly until the surface is freely covered. Now drop on the plate's surface a few drops of an alcoholic solution, asterisk. Asterisk, this solution is composed of equal parts of alcohol and water, for the summer, and in winter 3 parts alcohol to 1 of water. A few drops of potassium solution may be added, and is known to have a decided effect upon the plate. Take a patch of Canton flannel. In order to prevent the moisture from the hand, it should have a thick, firm texture. With this, rub the plate in circles across. Then back, covering 1/2 of the former row of circles in each crossing until you have gone over the plate and back to the point of beginning, occupying at least half a minute in the operation, for a small plate, and so in proportion for the other sizes. Care should be observed to keep the patch wet with the alcoholic solution, forming a paste on the surface of the plate. The motion of the hand should be brisk and free, not hurried, and the pressure about equal to that of a pound weight. When the cotton is disposed to adhere to the plate and slip from under the finger, spread the fore and middle fingers a little apart, then pressing down, bring them together in such a manner as to form a fold in the cloth between them, by which means you will hold it perfectly secure. Avoid wetting the fingers, and should they perspire, wipe them often, as the moisture penetrating the cotton and coming in contact with the plate would cause streaks it would be difficult to remove. I will here remark that many operators use much more cotton flannel than there is need of. I have found in my experience that a single patch, about 1½ inch square, will be better for cleaning a number of plates than a new piece for every plate. This is the case for the wet, and for the dry rubbing 2 or 3 pieces will be found to answer. Thus with 4 or 5 cloths a dozen plates may be prepared. Some operators use prepared cotton, and think it more convenient than the flannel. This may be had prepared free from seeds and in a very perfect state, if wished. In going over the plate, great care should be observed in touching its surface as equally as possible. The greatest care should be taken neither to touch the plate with the fingers, nor that part of the cotton flannel which is to come in contact with its surface. Take a clean piece of flannel by one corner, snap it smartly to free it from dust and loose fibers, lay it face side upward, dust on a little fine rotten stone. With this, polish around, or across, or in circles, lightly and briskly, passing gradually over the whole surface of the plate, as was done before with the wet. The plate should now exhibit a bright, clear, uniform surface, with a strong metallic luster, perfectly free from any appearance of film. If not, the last polished should be continued until the effect is obtained, and when once obtained, the plate is ready for buffing. Buffing the plate. There are a variety of ways and means employed in this part of the operation. Some choose wheels, and others prefer the ordinary hand buff. I have been unable to detect any peculiar advantage in the use of the wheel except in the facility of the operation. No doubt, however, but there is a saving of time, particularly in the preparation of the larger plates. For general use, we have not seen a wheel better adapted for this purpose than the one patented by Messrs. Lewis It is generally well to use a hand buff before placing the plate on the wheel. This is in order to prevent, as far as possible, the dust or other substance that may be on the surface of the plate from coming in contact with the cover of the wheel. I will here follow out the use of the hand buffs. 2 are necessary, as they are mostly used in the morning. Before using the buffs, brush both as clean as possible, in order to free them from dust. Then with the blade of a pair of shears, held perpendicular, rub the buffs from end to end. Then knock them both together in order to free them from all dust or other substances, occasionally exposing them to the sun or to the fire. With one of the buffs, reserving the finest and softest for the last operation. Powder its face with fine rouge and brush off slightly, leaving only the finest particles in it. Every operator should have 2 plate holders, one for cleaning and one for buffing the plate, for when using only one, the rotten stone is liable to get on the buff and scratch the plate. Rest the fingers of the left hand on the back of the buff, near the farther end, with about the same pressure as in cleaning, while with the right you bear on the handle to correspond, and give the buff a free, easy, horizontal motion, passing it very nearly the whole length over the plate each time. Continue this operation in such a manner that the plate will on all parts of its surface have received an equal amount of polish. This buff once well filled with polish, add but little after, say a small quantity, once in 2 or 3 plates. The polish as well as the buffs must be kept perfectly dry. The second buff should always be in the best order, and if this is the case, but little polish after the first need be used. Much depends upon the last finish of the surface of the plate, and as a fine impression is desired in the same ratio, the operator must exercise care and skill in this operation. Some buff the smaller plates on the hands by resting them on the fingers in such a manner that the buff cannot touch them. Some by holding the edges with thumb and little finger, with the remaining fingers under or on the back, and others buff on the holder. When this last method is adopted, it requires the greatest caution to prevent the dust from getting on the buff. The holder should be wiped clean. The plate frequently slips off or around, and the buff comes in contact with the bed of the holder. When, however, the operator is so unfortunate as to meet with this mishap, the utmost care must be observed in thoroughly cleaning the buff cover before further buffing. In this last buffing it may be continued as before, except without the application of polish powder to the last buff. Examine the surface occasionally, and buff more lightly towards the close of the operation, using at last the mere weight of the buff. This last buffing should occupy as long a time as the first. The point to be aimed at is the production of a surface of such exquisite polish as to be itself invisible, like the surface of a mirror. The secret of producing pictures discernible in any light lies in this. The more dark, deep, and mirror-like the surface of the plate, the more nearly do we approach to perfection. In all cases, very light and long-continued buffing is productive of the greater success, since by that means a more perfect polish can be obtained. The question is often asked, why is it that the plates receive the coatings so unevenly? I will answer by saying that it may arise from 2 causes. The first and most general cause is that those parts of the plate surface which will receive the heaviest coating have been more thoroughly polished, and the consequence is that it is more sensitive to the chemical operation. Second, and might perhaps be considered a part of the first, the heat of the plate may not be equal in all its parts. This may arise from the heat caused by the friction in buffing. It is a well-known fact, with which every observing practitioner is familiar, that a silver plate at a temperature of 45 degrees, or less, exposed to the vapors of iodine, is less sensitive and takes a longer time to coat than when it is at a temperature of 60 degrees, or more. Whenever a view is to be taken, or any impression which requires the plate to be turned on the side, it should be buffed in the other direction, so that the marks will always be horizontal. When the picture is in position, with the finest possible polish, the plate is ready for the coating box. The question is often asked by operators, What is the state of the plate when polished and allowed to stand for a time before using? To meet this point, we here only to consider the silver and the power acting upon it. Pure atmosphere does not act upon silver, but we do not have this about in our operating rooms, as it is more or less charged with sulfurated hydrogen, which soon tarnishes the surface of the plate with a film of brown sulfurate. It is this that sometimes causes the specks which appear on finishing the impression, and are a great annoyance. Hence we see that the plate should be buffed just before receiving the vapor of iodine. Mr. Hunt gives his opinion of the use of diluted nitric acid as the best solution for freeing the surface of the plate. He says, numerous experiments on plated copper, pure silver plates, and on silvered glass and paper have convinced me that the first operation of polishing with nitric acid, etc., is essential to the production of the most sensitive surface. All who will take the trouble to examine the subject will soon be convinced that the acid softens the silver, bringing it to a state in which it is extremely susceptible of being either oxidized or iodized, according as the circumstances may occur of its exposure to the atmosphere or the iodine. I cannot see the objection to this solution. However, in general use, our operators do not find it of sufficient importance to the success of their pictures to accept it, the alcoholic solution being in its nature less objectionable. I will say here that a plate submitted to only an ordinary polish is found to contain numberless minute particles of the powder made use of. Should the same plate be buffed for a long time, the polish will nearly all disappear, leaving the cavities in the surface free for the action of agents employed in subsequent operation. For this reason, I find that great amount of polishing powder should not be applied to the last buff, and it is obvious that 3 buffs can be employed to adventure. The 2 last should not receive any polishing materials. I have examined a plate that was considered to possess a fine finish, and similar had produced good impressions. These same plates, when subjected to a long and light buffing, would present a surface no finer in appearance to the naked eye, but upon exposure to the solar radiation, would produce a well-defined image in 1/4 less time than the plate without the extra buffing. Coating the plate. For this purpose our mechanics and artists have provided a simple apparatus called a coating box, which is so arranged as to be perfectly tight, retaining the vapor of the iodine or accelerators, and at the same time allowing, by means of a slide, the exposure of the plate to these vapors. They can readily be obtained by application to any dealer, all of whom can furnish them. The principal difficulty in coating the plate is that of preserving the exact proportion between the quantity of iodine and bromine, or quick. It is here necessary to say that hardly any 2 persons see alike the same degree of color, so as to be enabled to judge correctly the exact tint, i.e., what one might describe as light rose red might appear to another as bright or cherry red. Consequently, the only rule for the student in daguerreotype is to study what appears to him to be the particular tint or shade required to aid him to produce the desired result. Practice has proved that but a slight variation in the chemical coating of the daguerreotype plate will very materially affect the final result. The operator will proportion the coating of iodine and bromine or accelerators according to the strength and composition of the latter. Experience proves that the common impressions, iodized to a rather light yellow-gold tint, and brought by the bromine to a very light rose color, have their whites very intense, and their deep shades very black. It is also known that if you employ a thicker coating of iodine and apply upon it a proportionate tint of bromine, so as to obtain a deep rose tint, delineations will be less marked, and the image have a softer tone. This effect has been obvious to everyone who has practiced the art. Thus I may observe that the light coatings produce strong contrast of light and shade, and that this contrast grows gradually less, until in the very heavy coating it almost wholly disappears. From this it will readily be perceived that the middle shades are the ones to be desired for representing the harmonious blending of the lights and shades. Then, if we examine, with respect to strength, or depth of tone, and sharpness of impression, we see that the light coating produces a very sharp but shallow impression, while the other extreme gives a deep but very dull one. Here, then, are still better reasons for avoiding either extreme. The changes through which the plate passes in coating may be considered a yellow straw color or dark orange yellow, a rose color more or less dark in tint, or red-violet, steel blue or indigo, and lastly green. After attaining this latter color, the plate resumes a light yellow tint and continues to pass successively a second time, with very few exceptions, through all the shades above mentioned. I will here present some excellent remarks upon this subject by Mr. Finley. This gentleman says, "It is well known to all who have given much attention to the subject, that an excess of iodine gives the light portions of objects with peculiar strength and clearness, while the darker parts are retarded, as it were, and not brought out by that length of exposure which suffices for the former. Hence, statuary, monuments, and all objects of like character were remarkably well delineated by the original process of Daguerre, the plate being coated with iodine alone. An excess of bromine, to a certain degree, has the opposite effect, the white portions of the impression appearing of a dull, leaden hue, while those which should be black, or dark, appear quite light. This being the case, I conclude there must be a point between the two extremes where light and dark objects will be in photogenic equilibrium. The great object, therefore, is to maintain, as nearly as possible, a perfect balance between the two elements entering into union to form the sensitive coating of the plate, in order that the lights and shades be truly and faithfully represented, and that all objects, whether light or dark, be made to appear so far conformable to nature, as is consistent with the difference in the photogenic energy of the different colored rays of light. It is this nicely balanced combination which ensures, in the highest degree, a union of the essential qualities of a fine daguerreotype, viz., clearness and strength, with softness and purity of tone. So far as I know, it is the universal practice of operators to judge of the proportion of iodine and bromine in coating the plate, by two standards of color, the one fixed upon for the iodine, the other for the additional coating of bromine. Now I maintain that these alone form a very fallacious standard. First, because the color appears to the eye either lighter or darker, according as there is more or less light by which we inspect the coating. And secondly, because if it occur that we are deceived in obtaining the exact tint for the first coating, we are worse misled in obtaining the second. For if the iodine coating be too light, then an undue proportion of bromine is used in order to bring it to the second standard, and vice versa. The iodine box should be kept clean and dry. The plate immediately after the last buffing should be placed over the iodine, and the coating will depend upon the character of the tone of the impression desired. Coating over dry iodine to an orange color, then over the accelerator to a light rose, and back over iodine 1/6 as long as first coating, will produce a fine, soft tone, and is the coating generally used for most accelerators. The plate iodized to a dark orange yellow, or tinged slightly with incipient rose color, coated over the accelerator to a deep rose red, then back over iodine 1/10 as long as at first coating, gives a clear, strong, bold, deep impression. I will here state a singular fact, which is not generally known to the operator. If a plate, coated over the iodine to a rose red, and then exposed to strong dry quick or weak bromine water, so that a change of color can be seen, then recoat over the iodine twice as long as at first coating, it will be found far more sensitive when exposed to the light than when it has been recoat over the iodine 1/4 of the time of the first coating. Probably the best accelerating combination is the American compound formerly known as Gurney's American compound, or some of the combinations of bromide of lime. The first is thought to possess perhaps more uniformity in its action than any other combination I have ever used. The plate once coated should be kept excluded from the light by means of the plate holder for the camera box. I will notice one of the principal causes having a tendency to prevent the perfect uniformity of chemical action between the iodine and silver hydrogen, or the moisture in the atmosphere, makes a very perceptible barrier. This moisture may arise as the result of the cold, from a want of friction in the buffing of the plate, which, coming in contact with the warmer air, as a writer on this subject says, it is well known that as often as bodies, when cold, are exposed to a warmer air, the humidity contained in them is condensed. It is to this effect that we must attribute the difficulty experienced in operating in most cases. This is corroborated by the results experienced by our operators. So it is seen that the plate should be of a temperature above that of the atmosphere. Mr. Gurney submits his plates to a gentle heat from a spirit lamp just before exposing them to the vapor of iodine. Experience has convinced me that a plate heated to about 80 degrees before being exposed to iodine will present a far better defined image than a plate at a temperature of 50 degrees. I account for this by noticing that, at a higher temperature, the plate throws off any larger crystals that might otherwise be deposited, receiving only the finer, thus producing a more perfect chemical combination of iodide of silver. I would call the attention of the operator to this point as presenting something of interest and which may direct in a way of accelerating the future operations. That the presence of a film of moisture over the plate is a preventive of uniform chemical action may be readily understood from the fact that iodine is almost insoluble in water, requiring 7,000 parts of water to dissolve 1 of iodine, or 1 grain to a gallon of water. Yet its affinities for silver and other substances are so powerful as to prevent its existing in an insulated state. Hence, we can account for the frequent occurrence of a plate presenting parts of an image over its surface. It is quite evident that those parts of plate's surface covered with moisture are nothing like as sensitive to the iodine as those parts perfectly free. Exposure of the plate in the camera and position. The time of exposure necessary to produce an image upon the daguerreotype plate can only be determined by experiment, and requires a liberality of judgment to be exercised on the part of the operator. The constant variation of the light renders it impossible to lay down any exact rule upon this point. Light is not alone to be considered. The amount of coating exercises a deviating influence. Also, the subjects to be represented are not equally photogenic, some requiring much longer time of exposure than others. This may be easily observed by exposing the plate at the same time to a plaster bust and a piece of black velvet, the first being a much stronger reflector of light than the latter. The time necessary to produce a well-developed image of the velvet being about 6 times longer than that required to produce an equally defined image of plaster. The manner of judging correctly of the time is by the appearance of impression after it has been developed by the mercurial vapors. Should it present a deep blue or black appearance, it is solarized or overtimed. This sometimes is to an extent that a perfect negative is formed, the white being represented black, and the dark light. An object requiring the particular care and attention of the operator is the proper focus.